Hey, welcome back. This is Math College Algebra 1530, and we want to work with dividing polynomials today. Okay, so let me clean this up. It's section 2.4, dividing polynomials. And we'll also have some theorems and synthetic divisions also in here, which is kind of a short way to do polynomial division. Okay, so let's dive right in and take a look. So first we have the normal run-of-the-mill long division type problems. Okay. So for example, number 3, well, it used to be number 3, I'm not sure which one it is now, so we'll just put example. So we have x cubed plus 5x squared plus 7x plus 2 divided by x plus 2. Okay, so you do it like you did in arithmetic. All right. So I'm going to put the x cubed plus 5x squared plus 7x plus 2 inside the division symbol here. And then on the outside you put x plus 2. And then up top you say, what times x is going to give me x cubed? You multiply it by x squared, right? So x squared times x is x cubed. When you do this, you have to multiply all of x plus 2 times x squared. Right? So it's x squared times x plus 2. And then it's not just the x cubed that you're going to be subtracting away. It'll be x cubed times plus 2x squared, sorry. Okay, and then you subtract. If you remember in arithmetic, that's what you did. You subtracted. And you have to subtract the whole thing, not just a piece of it, so we put those parentheses there. So it'll be x cubed minus x cubed is 0. And then 5x squared minus 2x squared. That will be 3x squared. And then you just bring down the next term, 7x. Okay, and you repeat. What times x gives me 3x squared? Well, that will be 3x. Right? So in my brain, I have to remember to distribute. 3x times x plus 2. I'm going to put that in blue, but I didn't. There it is. So I'll have 3x times x is 3x squared. And then 3x times 2 is 6x. Okay, and then we subtract, right? Okay, so 3x squared minus 3x squared is 0. 7x minus 6x is 1x, and then plus 2. And so what times x plus 2 is x plus 2? Or what times x is x. So you just go plus 1, and it turns out to be the same thing. So 1 times x plus 2, I'm kind of thinking in my brain, gives me x plus 2. Then you have to subtract the entire thing. And what do you end up with? You end up with 0. So 0 remainder. So in this case, the answer is just this thing in, on top of the division symbol. Okay, so x squared plus 3x plus 1. Okay. Later we'll see this is a cool way of actually factoring polynomials, because if you wanted to, and we'll talk about this again here in a second, but if you wanted to, we could write x cubed plus 5x squared plus 7x. You don't have to write this down. Plus 2 divided by x plus 2 equals what? X squared plus 3x plus 1. That's exactly what I have written. Okay, when I started, I just use a division symbol instead of the bar instead of the division symbol. Okay, I can multiply both sides by x plus 2 in this equation that I'm boxing in. Multiply both sides by x plus 2. And if you do that, you end up with x cubed plus 5x squared plus 7x plus 2 equals x squared plus 3x plus 1 times x plus 2. So what you end up with is a factorization of this x cubed thing. Okay, so it's only going to happen when you get that remainder 0, but it's kind of a clever trick that we'll take advantage of to do some factoring later on. Okay, let's look at another example. So this time we have 4x squared minus 8x plus 6. And we're dividing this thing by 2x minus 1. Okay. So I'll set up my division. Sorry, that thing keeps popping up. I don't know why. I think it has something to do with my pen. Here we go, 4x squared minus 8x plus 6. So again, I'm thinking to myself, what times 2x gives me 4x squared? So clearly 2x. 2x times 2x is 4x squared. So I'll have 4x squared, and then you have to remember to distribute the 2x to both terms. So 4x squared minus, then 1 times 2x is 2x. And then I have to subtract the entire thing. Okay, so I'll have 4x squared minus 4x squared is 0. Negative 8x minus negative 2x is negative 6x, and then plus 6, bring down the plus 6. Then what times 2x is negative 6x? So I think that's negative 3. So I end up with negative 6x plus 3, and then I want to subtract. Okay, so negative 6x minus negative 6x is 0. 6 minus 3 is 3, and that's my remainder. Okay. You kind of know when you're done because the degree of the expression, the degree of this expression, if you didn't know, is 0. So you think of it like 3x to the 0th power or something, where x to the 0 is 1. This degree is less than the degree of the 2x minus 1 that you're dividing by. So when that happens, you're kind of done. Okay, and then you could write out your answer. So this, all this mess here with the division and the subtraction is not your answer. Your answer is the 2x minus 3. Okay, this part I'll circle in yellow. 2x minus 3 plus the fraction made by taking this ratio, 3 all over 2x minus 1. Okay, so we'll go plus 3 all over 2x minus 1. Okay, that is your answer there then. I'll circle it in blue. Okay, so, whoops, that's not blue. Okay, so that thing right there is the actual answer that we're after. Okay, clearly it can get much more complicated, and you could be called upon to have to do those kind of problems eventually, depending on your program of study. When they get really complicated, you probably want to use some placeholders. Okay, so in particular, if you have something like 4x to the 5th plus 2x cubed plus 3x minus 1, you could rewrite it using placeholders. So 4x to the 5th, you want to represent every one of the exponents. So 0x to the 4th plus 2x cubes plus 0x squares plus 3x, and then minus 1. Okay, so the placeholders will help you line things up. It's usually not necessary to write them. If you're working in arithmetic just with regular numbers, clearly the number 43 is much different than the number 403. You need that placeholder there, right? With polynomials, we usually don't need the placeholder because you could just look at the exponents and kind of know where you are. Okay, so I don't know. Anyways, let's take a look at one where we have to kind of go through this business. So we have 4x to the 4th minus 4x squared plus 6x divided by x minus 4. Okay, so when I do my, so I have the x minus 4 and I'm doing my long division. When I put in my numbers and my polynomial here, I'm going to use placeholders. Okay, so 4x to the 4th plus, I'm missing an x cubed, right? So 0x cubes minus 4x squared plus, I guess there's 6 x's, and if you want, 0 for the constant. Okay, you could also use placeholders on the outside. So if you had something like x squared minus 4, you could put x squared plus 0x minus 4. You could do that too. And it's solely so everything just lines up really well. When I did long division back in the day when I was a little kid, I didn't use placeholders, and I was still able to miraculously come up with the answer, right? So, I mean, the placeholders are nice, believe me. You don't want too much of a disaster on your hands when you go into working with some math problems. So if it's not lined up, that could just give you more headaches, right? So anyways, let's try. What times x is 4x to the 4th? Well, that would be 4x cubed, right? So 4x times x is 4x cubed to the 4th. And then 4x cubed times negative 4 is negative 16x cubed. then you do your subtraction. Okay. Okay, so 4x to the fourth minus 4x to the fourth, 0. 0x cubed minus negative 16x cubed is positive 16x cubed. Sorry, I don't know why that thing keeps flopping in there like that. Let's bring down the next term, negative 4x squared. So what times x is 16x cubed? Well, 16x squared, right? So 16x squared times x is 16x cubed. That'll take care of that term. And then 16x squared times negative 4 is negative 64x squared. Okay. So negative 4x squared, well, the 16x cubes will cancel, and then negative 4x squared minus negative 64x squared. That's going to be 60x squared, and then bring down the next term. Okay. So what times x is 60x squared? Well, that will be 60x. So you'll have 60x squared minus 60 times negative 4 is minus 240x. And then you have to subtract 60x squared minus 60x squared. Minus 240, 6x minus negative 240. So that's going to be 6x plus 240. X, which is 246x, and then what times x will give me 246x, so plus 246. Okay, and so 246 times x is 246x, and of course you could bring down this plus 0, so you have a plus 0 there. 246 times negative 4 is negative 984. And then we have to subtract again. So negative 984 will be positive 984. And so our final answer, right, is going to be 4x cubed plus, I don't know why this thing is being such a jerk. I must have accidentally hit a button or something. 4x cubed plus 16x squared plus 60x plus 246. And then plus, then you do your fraction thingamajig here, 984 divided by x minus 4. Okay. Plus 984 divided by x minus 4. Okay. Okay, so that's the long and the short of it. Let's move on to the synthetic division. Okay, so this is section 3, synthetic division. So basically, if you're doing a lot of this polynomial division, you need to have a kind of a shorthand way of handling it, and this will give us a shorthand way of handling it. The only problem is if you try to do it in general, it won't always work. Basically, your divisor has to be in the form x minus some constant. Okay, so if you look above, we could do synthetic division on this example. Okay, we could do synthetic division on, well, we can't on this example. Okay, so here the 2x minus 1 is bad news because you have that 2 in front of the x, so you wouldn't be able to do synthetic division here. Then the last example, you could do synthetic division, right? You just have x plus 2. So it doesn't always work. Secondly, you have to use these placeholders. Okay, so placeholders will be required to make things line up nice. And the idea is you're kind of eliminating the variables. So no variables involved. I guess I'll just write that. No variables. Leave them at the door. Okay, so let's take a look at how this works. We got an example. We have 2x squared plus x minus 10, and then divided by x minus 2. Okay. I want to figure out what that is. So what you're going to do is go to, you take the coefficients of your terms here. So you'll have 2, 1, and then negative 10. Okay. And then in the box over here, you're going to put 2. You put the opposite of whatever this number is over here that I'm kind of underlining in blue. You just take the opposite of that and put it here. Okay, okay. And now the operation begins. So to get it started, you drop this 2 down. You just put a 2 here. And then you're going to go, let me put this maybe in a different color. You drop the 2 down. Then you're going to go 2 times 2 and put that result right here. And then you're going to add. Okay. So 2 times 2 goes there. It's 4. And then 1 plus 4 is 5. And then you just repeat. Okay. So 2 times 5 is 10. And then 10, negative 10 plus 10 is 0. Okay. And that's your polynomial, basically, your result. It'll be 2x plus 5, and with 0 remainder. So this equals 2x plus 5. Okay. Let's try another one. So sample, we have 5x cubed minus 6x squared plus 3x plus 11 divided by x minus 2. Okay. Okay, so again, list out all the coefficients here. And then in the box, we put the opposite of whatever this number is. So it's negative 2, so we put 2 in this box. And then we begin. So drop down the 5. 5 times 2 is 10. Put that here. Negative 6 plus 10 is 4. 2 times 4 is 8. 8 plus 3 is 11. And then 2 times 11 is 22. 11 plus 22 is 33. Okay, so your answer, let's maybe box this off. Your answer will be 1 degree less than the original polynomial. So if this is 5x cubed, this polynomial will be x to the 4th, have a degree 4. So the coefficient 5x to the squared, sorry, 1 less. 5x squared plus 4x plus 11, and then we have this remainder. And what you do is take this number and put it over x minus 2. So then plus 33 all over x minus 2. Okay. Okay. Let's try one with now placeholders. So getting more complicated. Section 4, synthetic division with placeholders. Okay. Let's see if I can fix this thing really quick. I'm hoping whatever I did kind of fixed the problem. Who knows? Synthetic division with placeholders. So let's try another example then. And what do we have? X to the 7th plus x to the 5th minus 10 x cubed plus 12 divided by x plus 2. Let's figure this out. Okay, so first get the, so you have to watch it now. We need placeholders, right? So it's like x to the 7th plus 0 x to the 6th plus 1 x to the 5th plus 0 x to the 4th. Okay, so you have to be careful. So I have the 1 from the x to the 7th, then there's 0 x to the 6th, there's 1 x to the 5th, 0 x to the 4s, negative 10 x cubes, 0 x squares, 0 x's, and then 12 for our constant. From the denominator, we're going to be putting negative 2 in the box, and then we'll go through and evaluate it. Okay, so immediately bring down the 1, then negative 2 times 1 is negative 2, and then add 0 plus negative 2 is negative 2. Negative 2 times negative 2 is positive 4. 4 plus 1 is 5. Negative 2 times 5 is negative 10. 0 plus negative 10 is negative 10. Negative 2 times negative 10 is 20. 20 minus 10 is 10. Negative 2 times negative 10 is negative 20. 0 plus negative 20 is negative 20. Negative 2 times negative 20 is 40. 0 plus 40 is 40. Negative 2 times 40 is negative 80. And then finally, it looks like we have negative 68 for our remainder. Okay, so that would have been a nightmare doing it by long division. Let's go ahead and write it out. So we should begin with 1x to the 6th, 1 power less than the x to the 7th. minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared minus 20x plus 40 minus, or if you'd rather, plus minus 68 all over x plus 2. Okay, so you can put the minus in the numerator there, or if you'd rather, you can kind of just plop it out in front like this. Either way will work. Okay, but that's it with the placeholders. Little annoying. Okay, so let's get the other these. We have some high-powered theorems that we can use. The first one's called the remainder theorem. And these are kind of unusual curiosities, but we can exploit these facts in order to to do some operations quickly. Okay, so in mathematics and especially in computer science, they're always looking for quicker ways to do things. Basically, you can count up the number of operations you have to do, and they want to reduce the number of operations, right? The longer it takes to do something, you know, there are things that literally would take to the end of the universe to do. And if you can find quicker ways to do it, you can do it before the universe ends, right? And then you would have an answer. So it's not like some things are unanswerable. It's just that some things out there take so long to answer that all of existence would be gone by the time we had the answer. Okay, so computer scientists and even mathematicians will try to find ways to reduce the number of computations, therefore allow us to unlock these answers. And so we're always looking for different ways to do things, and we could use the remainder theorem as a different way of figuring something out. So this is the problem. Somebody gives you this polynomial, 2x cubed minus 11x squared plus 7x minus 5. And then they say evaluate f of 4. Okay. So you could type it into your calculator, right? You use 2 times 4 cubed minus 11 times 4 squared. It's just, it can kind of be a nightmare, and maybe you'll make a mistake. You don't put a parentheses in the right place. Well, you could use long division to pull it off. Okay, so 4, 2, negative 11, 7, negative 5. I can do this really quick. Bring down the 2. So 8, negative 3, negative 6, 1, and then 4. So the answer is negative 1, believe it or not. Okay, or rather, I must have made a mistake somewhere. Oh, great. Did I copy it down wrong? What did I do? Oh, I see what I did. 4 times negative 3 is negative. So this is one of, you know, negative, what's 4 times negative 3, people? It's negative 12. I was hoping to be all cool. No, it's not going to happen. All right, so anyways, yeah, 4 times negative 3 is negative 12. Negative 12 plus 7 is negative 5. And then negative 5 times 4 is negative 20. So the answer is actually negative 25. Sorry about that. Negative 25. So it changes having to do a bunch of harder multiplication into an easier problem. So look what would normally transpire. You'd have to go 2 times 4 cubed minus 11 times 4 squared plus 7 times 4 minus 5. So that's 2 times 64 minus 11 times 16 plus 28 minus 5. 2 times 64 is 128. What is it, 176 maybe? 176, and then plus 28 minus 5. 128. Okay, so 6, 16, 8, 4. Negative 48 plus 28 minus 5 is negative 20 minus 5. Finally, minus 25. Okay, so look, a computer kind of has to do the same thing we have to do in order to get the answer. But it could find a quicker way, something that takes less operations, does addition instead of multiplication, because addition is usually easier to do than multiplication. If it takes us less time to do it, it'll probably take the computer less time to do. So you could then program the computer to do a problem that may take like 10 years. Instead, it takes a week, right? And then we can find the answers to the universe. Okay, so that's one neat factoid. Another neat theorem is the factor theorem, and I talked about this at the beginning of the lecture. Okay. So we can, if you do your division and you get a remainder of 0, you can use that. You can factor the initial polynomial. So, example, x squared plus 3x minus 10 divided by x minus 2. Okay. Okay. So we're just going about our daily business. So we could use synthetic division here. 1, 3, negative 10, and we're dividing by 2. Okay. So bring down the 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is, and lo and behold, we get 0. Okay. So x squared plus 3x minus 10 divided by x minus 2 is x plus 5. Okay. But we kind of already knew that, right? Because we take x squared plus 3x minus 10 and factor it, what do you think you're going to get? Well, you're going to get x plus 5 times the thing we divided by, x minus 2. So we're going to have kind of a guessing method in order to, we'll guess basically this number eventually, not maybe today, but later. We guess at this number. It's an educated guess. We have some theorems that will give us that number. And if we get a 0, we'll keep trying over and over again. If we get a 0, then we can do a factorization. And we could use this method to factor polynomials. Okay, okay, so let's take a look at maybe an example of that. Here we go. So we have 2x cubed minus 5x squared plus x plus 2 equals 0. I want to solve this given that somebody figured out x equals 2 is a 0. Okay, so in other words, when you factored that polynomial part, this 2x cubed minus 5x squared plus x plus 2, it's going to equal x minus 2 times something. And in other words, basically when you divide this polynomial by x minus 2, you're going to get a remainder of 0. Okay, okay, so how do I use that to then factor this thing, right? So if they say 2 is a 0, that's what you're going to be dividing by. Okay, 2. Then we do our polynomial or synthetic division. Okay. Bring down the 2. 2 times 2 is 4. 4 plus negative 5, negative 1. This will be negative 2. This will be negative 1. Negative 2, and of course that's 0. Okay. So what does that tell us? That tells us that this polynomial up at the top of the screen now can be broken down into x minus 2 times 2x squared minus x minus 1. Okay. And then that will equal 0. So I'm just taking this term here times this term here. Okay, that times that should give you this right here. Okay, and then I can even factor that more, I think. So this would be x minus 2 times 2x, and let's set up our parentheses, right? So x, and then minus 1, and then 2x plus 1, right? It has to be plus 1. And then set each part equal to 0, and you get your zeros, right? X equals 2 from that guy. 2x plus 1 is 0, so 2x is minus 1, so x is minus 1/2. And then x minus 1 is 0, so x is 1. So we get these three solutions to that problem. Okay, okay. Let's quickly look and see if there's anything worthy of our attention in my math lab. Okay, so I've been kind of neglecting my math lab lately. Let's see if we got anything. Okay, where's my homework? So this is section 2.4, I believe. And let's look at one of the later ones, right? Okay. Solve the equation. So that's just kind of what we were just doing. So let's take a look at that. Sure, why not? So we have 4x cubed plus 4x squared minus x minus 1 equals 0, given that negative 1/2 is a 0. Okay, so what you're going to do is put the negative 1/2 in a box, and then you have your constants. Okay, and you should get 0 as your remainder. If you don't, you screwed up. Okay, so bring down the 4. Negative 1/2 times 4 is negative 2. 4 minus 2 is positive 2. Negative 1/2 times 2 is negative 1. Negative 1 plus negative 1 is negative 2. Negative 1/2 times negative 2 is positive 1, so we did something right. Okay, so that's just 0. Okay, so I could take this polynomial from the top of the screen here and factor it into x minus negative 2. In other words, x minus negative 1/2. I'm thinking about this 1/2 thing here. If it says your 0 is negative 1/2, then that implies that the factor that you're going to use in your factorization is x minus negative 1/2. In other words, x plus 1/2. Okay, you just have to take the opposite sign. So you have x plus 1/2 times 4x squared plus 2x minus 2 equals 0. And then we could factor that even more probably. We can factor out a 2. Okay, so we'll have x plus 1/2 times 2 times 2x squared plus x minus 1, 0. I like to put the 2 out in front, so you can do that via the commutative law of multiplication. 2 times 3 is the same as 3 times 2. So x plus 1/2. And then let's see if we can factor this thing. Hopefully we can. So 2x and x, we get plus 1 and minus 1, and I think we're on our way, right? So the solutions, the negative 1/2, of course, from the first factor, and then 2x minus 1 is 0, so 2x is 1, and then x is 1/2. And then x plus 1 is 0, and x is then negative 1. So we get those 3 answers. Yay. I don't know if there's anything else we're seeing. I deleted some of these. They were just getting too carried away with all the rigmarole. The function f of x equals, so f of x equals 80x minus 8,000 all over x minus 120 in the interval from 40 to 100. Models tax revenue in tens of billions of dollars in terms of the tax rate x. So f of x is tax revenue in billions of dollars. Okay. Let's see, the graph of the function shows to the right. It illustrates tax revenue decreasing dramatically as the tax rate increases. At a tax rate of 100%, the government takes all of our money and no one has an incentive to work. With no income earned, $0 in tax revenue is generated. Complete parts A through C below. So find f of 40. So f of 40, you can just plop 40 into that function, I guess. So 80 times 40 minus 8,000 all over 40 minus 120. I need to get my calculator to do that. Okay, here we go. 80 times 40 minus 8,000 in parentheses divided by parentheses 40 minus 120 and parentheses is 60. So $60 billion of revenue. And I forgot to write down what the heck x was. X is the tax rate. You have a 40% tax rate. Okay, so 60. What what's next? Interpret your result. So I already did. When the tax rate is 40%, the revenue is $60 billion. Is it in hundreds of billions, or it's just tens of billions? Sorry. So in tens of billions. So it's 60 tens, which is 600. So the 40% with an additional 600 billion. When the tax rate is 40%, okay. Identify the solution as a point on the graph. So you just find 40, 60. So where the heck is it? 10, 20, 30, 40, 60. It looks like this. No. 10, 20, 30, 40. I mean, it's this point right here. Identify. Why are we? It's going from 40 to 100. So when it's at 40, oh yeah, it's a D. There it is. Use long division to simplify this thing. Okay, so let's do that. So I have, we can do synthetic if you want. So it'd be like 120 is your divisor, and then we have 80, and then minus 8,000. Okay. So bring down the 80, and then 120 times 80. Ugh. 120 times 80 is 9,600. We'll go right here. And then subtract those two, and of course you get 1,600. So our f of x formula will be, what is it? It's 80 plus 1,600 all over x minus 120. Sure seems like it. Let's see if it's in there. No. It's 80 plus 1,600 over x minus 120. It's thinking. So use this new form to find the answer. No, thank you. It's the same. 60. And is f a polynomial function? No, it's not, because it has that x in the denominator in the second term. Okay? It's this term that really screws it up. So no, it is not a polynomial because it's not written, can't write it in the form a sub n x to the n, etc. Okay, let's leave it at that then. Thanks for watching as usual, and I will see you next time.